Okay, it's 4:30, so it's about time to start final, let's say, section for today. And our speaker is already set up and running, ready for the talk. He came from Madrid, from Spain, and he's originally from Alicante. And he is a developer advocate for MongoDB. So we know that we need one in the team, so we have even two at the one conference. And Jorge is passionate about teaching mobile development and security, plus architecture and best practices. And next talk is actually about great software architecture and how to make that possible in the Swift UI. Three key aspects to remember from the talk: use cases, connectors, and other logic. So please welcome Jorge Ortiz.
So, thank you. This is going to be, as she said, about architecture. And we are going to talk about what you do. I'm really interested in knowing what you are currently doing. We will talk a little bit about presentation logic, a little bit more about use cases and how to do a factory for asynchronous use cases. And finally, we will talk a little bit about navigation. I will revisit some content that I created some years ago, but in this case, I will share it with you for Swift UI, okay? And that's going to be basically it, but there are a lot of slides, so I will try my best to keep it in time. I'm going to set up a warning here, so if I speak too much, I will know it. And I'm not talking about your family, I'm talking about your architecture. So if you want to complain, you can complain to my Twitter account. Feel free to send me any Twitter, complain, and say you are doing it wrong. This is the right way to do it. And we will have a discussion. I love to have discussions about that. I'm not saying that this is the absolute truth. Well, it is, but you have to accept it before you use it. And there are ways that you can implement architecture, and this is how few things that you can do in order to improve your architecture for your iOS application. So let's start with you instead of me, okay? Let's try to figure out what you actually do. I assume that everybody in the room, and I think that we will do better if somebody is not doing iOS applications. Oh, that's good. Okay, other than that, are you using Model View Model? Who is using Model View Model? Please, hands up. Okay. Well, most, I will add like a 10% shy people. I would say like 80% of the room was using MVVM. Are you using Swift UI already? For real, not for fake examples. So, Paul Hudson is going to be really sad about this. I mean, like, come on, guys. You have to buy Paul Hudson's materials. Please use Swift UI. So, finally, and if when you read this question, the thing that comes to mind is, what? And then the answer is no. So, do you isolate your persistence at all? Hands up. Well, I would say 20% as a maximum. Okay, so there is good ground here to discuss. And final one. Do you use any fancier thing regarding architecture? Hands up. Well, you don't consider your architecture fancy. That's good, because now when we discuss about it, you're going to say, oh, it wasn't that fancy. Okay, so let's discuss about architecture itself. And I don't know about you, but I have never seen anybody who buys an app from the App Store or even downloads it for free because of the architecture of the app. So that's something just for us. I mean, users couldn't care less about your architecture. They care about the side effects of having a good architecture, but not about the architecture itself. That is very important. It is not also about telling your colleagues how to do things properly because you are the smartest ones in the team. It is important that you agree with your team and you use some consistent way of implementing the architecture of your application. And you have to share knowledge and to listen to others in order to get that. And it's not about showing off how smart you are in order to do things and tricks with Swift UI and all this stuff. This is not about this. This is about how to do practical things in a way that is repeatable. And what we want to do here is to find patterns that are successful, that help us to do a good code that is testable, that is reusable, and use them once and again and again and again as much as possible. Because that is what will help us to have something that everybody in the team agrees with and that uses to improve the quality of your application. Okay, so this is a warning. I hope that you got your coffee. I hope that the cake was great, but please don't blink from now on because there is a lot of content. Keep your eyes like that. And the first thing that we're going to talk about is something that you know that when we talk about examples, usually we refer to Apple's examples. And we, as developers, we want to believe that we are smarter than them, that they do examples that are not as good as they should be, that they don't use the proper architecture in their examples. Let me tell you that I believe, I have some friends working for Apple, as you probably have too, but I believe that the examples there are not meant to have a good architecture described, but rather to show you how the features of some library or another work to make you understand how to use it in your projects. But one of the things that is usually wrong in those examples, and even in some examples online, is how to use presentation logic. And before we talk about how it is implemented, let me talk about what it is. In some applications, this is Omnifocus. I don't know if you have ever used this. This is like a time management, task management, however you want to call it, something to improve your life and to do things that you should be doing and not missing deadlines and not missing tasks that you should be doing. See here that you have two tasks and the color for the task is different depending on whether it is due soon or it is going to be, it was due before the time now. So this is overdue, the other one is due soon. And you have this information, which is not part of your domain logic. It's part of the status, is an information that is given to you as part of the presentation of the data. Same thing with a bank application. To be completely honest, I don't even know what this banking application is. I was looking for a screen capture that was showing this example, and there are several of them, so I took this one. But this shows like red for transactions that are getting money out of your account, while green means that you're getting money in, that you are happier now. Okay? Particularly for the amounts, you're much happier now. Okay? So, again, this doesn't affect the domain logic of your application. It only affects the way the information is presented to you, but it's relevant. It makes our users' lives easier because you provide this information. Even in Apple applications, in the weather app, you have several things, several ways of showing this information. For example, in the temperature range here for Singapore and the temperature range here for Kuusamo, which is in Finland, as you can see, it has colors to show, hey, you're freaking cold here and you are going to be sweating most of the time there, okay? So it's giving you information in a way that you can process faster without having to overwhelm you with bits and pieces of data. So in our applications, if you are already using Model View Model, you know that the view should be passive, it should be dumb as possible, but still useful. So it should be getting the user events and passing them onto the view model, which will provide the semantics to the view model, to the event, sorry. And those events, if they may trigger changes in the model, and it also will react to changes in the model that are notified to the view model. Finally, the view model updates its model to the view, that's why it's called the view model, and it will notify of those changes to the view, and the view will update itself. That's how it works. It's as simple as that. So what you want to have here in the view part is something that is very, very simple. As much as you can, you should avoid having logic there. So when you find things like this one, you will figure out that this is not exactly what you were looking for. So you have the text there, and you are doing the proper formatting for the string there, and you choose the color, and you have an if there saying whether this thing in the model was that or that other thing. If the amount of this bank transaction is positive, then I want it green. If it is negative, I want it red. Again, not what we want. This logic is now in the view and is harder to test. We want to have something that is easier to test. So instead, you can implement a transformation that will take care of that can be tested, and have this quantity processed in a single way by the view. It will be the view and this transaction color code that is going to be offered by the view model, the ones that have this information and that apply this way of presenting the data to the view, okay? So that is far easier to test, and it's an easy way to avoid having logic in the view. Well, no logic in the view. Is it clear? Do we agree? Sleepy? No. Okay. So I believe that this provides with a more consistent behavior, because if you do this, if you implement this in this transformation, you can reuse that part in several parts of your application. So your views will have a more consistent way of applying these colors. Instead of having to do this for each of the views, you will have a single way to implement this presentation logic, and it will be used across the whole application. It is easier to maintain and evolve, and it is easier to test the view models. The view models are far easier to test than having to do screenshots or screen captures of your application. I'm not saying that you shouldn't do that, but try to move as much testing of the logic to the view models themselves rather than to the views. Let's talk about reusing use cases. So sometimes we have the reputation of being data painters. I don't know if anybody has called you that, but as mobile front-end developers, sometimes we're told that we basically get data from the backend and we display it for our users on the mobile. And, well, in some cases, that is actually true. But in some others, we want to have some domain logic that is implemented in the mobile device. And if that is the case, you want to have that implemented in a way that is reusable, consistent. You know the song, okay? So what we would like to have is, in case that we have some operations, let's say that you want to do some media editing, or you want to have, even in the case that I'm going to show you, let's say that you want to implement a password manager. And you want to do things like generating a password given some rules. I want to have like this many characters, I want to have this many numbers, this many symbols, the rules that you want to apply. So in this case, you want to have this logic implemented in a way that it can be reused across your application in several views if you need to, and in a way that is easy to use. Let's talk about it. So this is the first thing the first way to implement this logic, and you can get this password from this generate password function with the parameters that will configure this function. That is not by itself a bad implementation. But if you're doing this in two views, well, you have to basically copy and paste the same code, and you have to be consistent with the parameters that you move there. And, well, testing this independently, testing the view model independently of the password generation function becomes harder because the function is invoked exactly there. So decoupling this code gets harder. So, and as I was saying, there is some repetition that is going to be needed. There is problems with coherence because you may use a different implementation in some other part of your application, and testing is harder. So the first thing that comes to mind is, hey, let's encapsulate that logic in an object so we can inject it wherever we want to in other parts of the application. So what we're basically doing is generate a use case that is going to be a class, and this class is going to be a dependency of each of the view models that require this password generation. Okay? But the problem with this is that you have basically the creation of that is going to be needed in place because you need the parameters that we were mentioning before. So you need to create the object. You know that every time that you create an object in one of your view models, a kitten dies. So you shouldn't do that. That means that it's harder to test. So as much as possible, you should inject those objects. And sometimes you don't have the right parameters to have the object created beforehand. Testing is harder because of that, because the object was generated in place. And the input and the output of the use cases might be completely different. In this case, we have some parameters, and we generate a password, which is a string. But in some other cases, you may have no output and several inputs, or the other way around. So every use case can be different, and it's going to be different. So how do we provide more consistency? Well, there is a design pattern that is called the command pattern. I don't know if, I assume that many of you have heard about it, but basically the command pattern is to encapsulate some functionality in an object, and the object will implement this protocol. The protocol is a simple function that takes no inputs and returns no outputs, and has like the execution method. That is the one that is going to be triggering the functionality that we were mentioning. Okay, so probably you're saying, no input, no output. How do I get this? How do I get exactly the behavior that I needed? Because I'm going to use parameters, and I want to get a password back. So basically what you're going to do is to create, again, your class, and you are going to use the initializer, constructor for the rest of the world, for us, initializer. You are going to use your initializer to pass the parameters that you're going to need, and also to send a closure which will consume the data that is going to be returned from this use case. In this case, a single string, okay? That will work. That will generate a use case that you can have. And not only that, you can now have a factory which will provide you with all the use cases. The factory is very simple. The factory is just a single class. It has a method for each of the things that you want to generate, and those things can be generated in place. So for this generated password use case, you will get an object that implements use case. You couldn't care less about the actual object. You just care about it implementing the command pattern, okay? So now that you have that, you can go, and inside of your view model, you can respond to the event of the user tapping on the button, on the generate password button, and you create on demand a use case for that, and you execute that use case. Much easier, because now, imagine that you are writing Photoshop. Does anybody here work for Adobe? No, okay. Because I'm going to talk about the use cases, the many use cases that you have in this big palette of use cases in Photoshop. Imagine that you have this palette inside of your application. Now you can go and use all these use cases from wherever you want within your application. Very important, because now that provides you with a big flexibility and a huge consistency. The use cases are going to be exactly the same. You implement them once, you evolve them, you maintain them, you fix the bugs in just one place. That's what we're looking for when we're writing good architecture. So, yes, but funny that Diego and I have the same picture. We didn't talk about that, but we had the picture about Willy Wonka. In this case, I believe that that was good, but we have been provided with a solution to avoid having closures and have instead a very far more clear way of writing code, async await. Does it ring a bell? And we want to have that. I mean, like having now these factories with this closure sounds like outdated. You don't want to have that. You don't want to have something that you have to provide a closure to work with it. So how do we do that? Well, the problem here is that we want to have something like this, something that is async, that may throw an error, and this function is invoked as if it were a regular function. Not exactly, because you need to be in the context of a task, so you need to have some asynchronous context in order to invoke that function. But other than that, you are going to invoke it and receive the parameters. That is against the architecture that I was mentioning before. So we cannot use the closures here. It wouldn't, I mean, I would be using closures for something that is meant to avoid closures. The input and output are, again, different, and that is good, but bad for our factory. And we also require this color function environment to be able to invoke that function. So how do we do this? Well, basically, what we are going to do is to create two enums. These two enums are going to be one for the input and the other one for the output. The one for the input will have associated values for each one of the things that you need to pass for each of the use cases that you have. So you will define for this use case, one case of the enum, which will identify this use case with the parameters that are required for that use case. And then you will have the other enum that will be, it might be empty if this use case doesn't return anything. In this case, it returns a string, so it will have the associated value of a string, which will provide you with the generated password. Now, we can take advantage of this in order to define our command pattern, and we're going to define an asynchronous use case as something that implements exec, takes the input enum, and returns some case of the output enum. That way, we have created an homogeneous way of treating with all the use cases. It's a pain to create the enums, but it's the way you deal with a factory. So by doing that, you will have that use case implemented as we were saying before, and everything is going to be implementing this async throws and for all the use cases of the factory. So we get easier dependency injection, on-demand consumption as we were looking for, and we have all the capability to have all the use cases asynchronous or to deal with asynchronous storage. Let's say that you want to use Fira's library and you want to make it asynchronous, or let's say that you want to use Realm and have it talking to the Aldas cluster in order to synchronize the data. You can do that by using asynchronous use cases. Okay, that was for the factory. And now let's talk about navigation. How many of you are familiar with this picture of clean architecture? I would say most of you. Well, at least many of you raise your hand. The ones that are sleepy, please. So if you look at this picture, you will realize that it has entities, interactors, which I refer to as use cases, because I believe it's far more intuitive to understand that these are use cases. You also have the presenters or the view models, if you are referring to this case. You also have some way of isolating the persistence. And in the outside layer, you have like everything that is platform dependent. But there's nothing for navigation. Navigation is nowhere to be found there. There is no reference to the navigation. We want to have navigation to be consistent with our architecture, to have the independency between events, like the fact of you clicking on some button, with the fact of this application navigating to some destination. That has to be different. We want to be able to provide dependency injection for all of the destinations that we're visiting. We want to make it Swift UI compatible. I mean, there have been ways of doing this when we were using UIKit for a while, and there are ways to do it with Swift UI, and I'm going to present you one. And We would like to have some flexibility. We want to be able to rewire our application as much as possible. So we want to say, now, before we were navigating from here to here, I want to navigate from here to there. Or even I want to do programmatic navigation. I want to do A/B testing and say, if this has some value, I will take you this way. Or if it has another value, I will take you this other way. Or things like that, okay? So let me present you with the usual suspects here. We have already talked a little bit about a few of them. The view, we were talking about passivity, about beautiful face, and is the one that receives the user events and pass them onto the view model. It's the one that knows how to do the navigation. Does navigation link ring a bell for you in UIKit? In Swift UI? So this is the guy who knows how to do navigation. The view model is the brains here. Is the one that transforms the event into some semantic. And in order to do that, it has to get the event and decide this is the logic that has here and expose something in the view model as a property that will be consumed by the view. It notifies the changes, exposing this property, and it knows when and where to navigate. The destination is chosen by the view model. And the one that you probably don't know, which is the connector. I call it the connector because I like calling it the connector. You can call it whatever. This is my guy, and I call it connector. So what I'm presenting here is somebody who will take care of doing this dependency injection and doing the navigation. Basically, you are going to have the first connector creating the first view, and using that connector that gets injected in the first view, you will navigate to the next one, getting a connector for each one of the destination views. Let me show you a very simple example and evolution from bad navigation into something that I believe could be better, okay? So this is coupled navigation. You have the navigation link, and then you have the destination view inside of the navigation link. I mean, nobody's going to take you to jail because of that, but it's, I would say, bad, okay? The thing here is that you have no way of controlling where you're navigating to or decoupling that or doing the dependency injection that we were looking for. So we could do better. Let's do better. So the first thing that you can do is trying to implement programmatic navigation. So now you have the navigation link, but the navigation link has this $navigate, this state property that can be, in this case, is exposed by the button, is changed by the button, but it could be provided by the view model, okay? I didn't have a space here to have the view model and the view in the same slide, but take my word for it. I mean, like, there's no change here. So the next thing that you can do is to have this connector. The connector will have basically these two functions that you have here. One is assembling. It is the one that is responsible for knowing how to assemble the parts for a view. So it knows for each view what is the view model that is required for that, and any other dependencies that have to be put in place for the view. So basically, invoking the connector assemble method, it will create that view with all the dependencies injected. Second one is navigate to, and the navigate to takes an enum with a case for each of the destinations that you want to navigate to. And those destinations will invoke the connector. Sorry about that. Siri has a different opinion about architecture. So these destinations will invoke the connector for building the destination view in that place, okay? So from the first one, you invoke destination 1 connector, and if you have more navigation, you will invoke destination 2 connector, destination 3 connector, which will create the view and inject itself to do the navigation of that view, okay? Very easy. So now, when you want to do the navigation, you use the connector that has injected itself in the view, and you say, hey, I want you to navigate to this view model, which is the view model that is in this view, with this property that is the enum case that it navigates to. Basically, what you are doing there is separating the event from the destination, and it takes you there when required. So basically what we were looking for. Navigation is decoupled. It is easier to do dependency injection because it's a single class that takes care of each one of the classes, and the destination can be chosen with logic. I mean, like the thing that I was saying before, saying in the navigate to, you can apply any logic you wish. You can say, oh, if you have a feature flag enabled, navigate to this destination because now this is what we are developing at this time. While for the production, for the release one, you're going to navigate to this one, which is the stable one, okay? So many things that you can do there. Time to finish with this. I hope that you've liked it. I believe that all these things, you should try them. There's still a hackathon that is going on. So this is a good chance of getting there and practicing with some real data. They have data. This is the GDELT data set, which is huge. So huge. You can use it in order to do a test for an application. It's free. You can just join or not tell anybody and just get the data and play it. If you're going to try these ideas, my suggestion is instead of testing those things in your production code base, be kind with your friends. Don't let them spit them in your coffee in the future, and instead use something else to try these ideas and find out whether they are useful to you or not. Okay? I believe that these four matters, the transformation that I was mentioning before for presentation logic, provides far more consistency and testability to your code. The use case factories, asynchronous use case factories, are a better way to have domain logic in a way that is consistent and asynchronous in your application. And the connectors allow you to decouple the navigation and provide extra functionality and dependency injection. So I hope that you like some of the ideas there. If you don't, feel free to tweet me and tell me how bad my ideas are. I would love to have the discussion. Also, feel free to grab me later while we are drinking and with empty hands, not with a glass in your hand and pushing it in my face. Feel free to make any comments. I will be glad to have a conversation with you. So thank you very much. Do we have some time for Q&A? What? How many? 15. I hope that Vitaly has some more presence in LeverX for the best question here. But if he doesn't, feel free to make your question as you wish. There's a question over there.
Okay. 5 minutes later.
Take your time, take your time.
Could you please raise the hand again? Oh, here you are.
Thank you for the presentation.
Thank you.
I have one question about like the connector. Could you go back to the slide where it was like returning the view?
Sure.
So
This one?
yes, so it is returning any view, right?
Yeah.
So if you are going to the new screen in the navigation link, it will return any view, and you will lose the whole type of the actual view.
There are ways to improve these.
And it's like an issue is that it will be like the power of SwiftUI, that is that the diffing mechanism is using like a type to compute diffs, and if it will be like any view, it will be like more power to compute these diffs will be required.
Okay, so 3 things. First, you're totally right. I agree with your point of view, and I think that is an issue. But first, I believe that you shouldn't optimize until you have an issue with performance. That is the first thing that comes to mind there. Second, I believe that there are ways to improve this, and you can be a little bit more. You know that any view is a type erasure of the view. So that is affecting the performance because it cannot cache the actual view. But also, it is true that if you are creating several navigation destinations, you are creating the destination every time you visit the navigation link. So there is a performance advantage and a disadvantage of having the actual view there. And sometimes you are creating several views that you're not going to use every time that you create it, just because they are inside of the navigation link destination. That is an important issue that people usually forget, and they realize when the code of the initializer of the destination view is invoked while refreshing the initial view, okay? And finally, again, you can tailor this if you have just a single destination. So this is just like the general case. If you're navigating and the case is narrower, you can make it narrower, okay? But there's no protocol in this that this connector is implementing. So you can tailor it to your needs. If you need some optimization, you can use that optimization, okay?
I was thinking now if like, for example, like providing the view builder closure, which will return some view, will be like solution to this problem. Like not specifying like the actual type, but like provide the view builder, like the same like where you're creating a button and you provide like a label as a view builder. Maybe
correct.
That will be good for performance.
Yeah, great comment. I agree.
Thank you.
Okay, anyone else?
There are a couple over here and one over there. Are you raising? Sorry, but the light doesn't. No, you're not raising.
Hands up, please. Who wanted to ask a question? There are some questions.
Purple over here. Go ahead.
Okay, so my main question is, because the connector you're creating it with for every view, if I understand it right, and what's with the case if you want to navigate in SwiftUI from any place in your app? So you have like navigation on, for instance, on error. So repeat that again, because main problem in SwiftUI right now is something like you are on some screen inside your app. There you are like on the third screen hierarchy. And for instance, you get an error from backend, and you want to display something totally different view. And can we somehow have the like main connector that is like state driven for all I don't know, app lifecycle?
So let me try to rephrase it to be sure that I did understand you. So basically your concern is about having to navigate at a higher level from the level you are in, and you want to know whether navigation would help on that at the level of the main connector, the root connector. Yes. Well, that could be an approach. Another approach could be just making the view with some state that you change and swipe based on that, and get rid of the rest of the hierarchy. There are several ways to do programmatic navigation there. It really depends on the use case. I wouldn't say that there's a single solution for every navigation problem there, but I believe there are solutions like the one that I just mentioned. And I think that it really helps to have the other stuff there together with this, and you are not missing anything for having this state changing the main navigation there.
Can I have a follow-up? Sure. So right now the navigation link, if I'm not wrong, it's working like that, that when you have it in view, it's creating the view inside it on the initialization of the first view. And if with the connector, it would like every time you initialize the new view, then the view inside the link and the connector and the view model will be initialized with it. And can we I know that we can make some lazy navigation link, and that will happen.
That is completely solved. So your concern is the thing that I was mentioning right before about, because it is in the navigation link, you are invoking the connector every time, and the connector will generate the destination view every time. And the thing is, even though that is not in the implementation there because of space, the enumeration is an optional. And it doesn't it creates an empty view for the no destination, which makes things much easier for that case. And I believe that's quite helpful. Was that your question? Or?
Yes.
Okay, but I hope that I have answered them both. The thing is, because you may, at some moment in time in the application, you may have no destination whatsoever, which is, and why should I spend time doing this, creating this destination destination view if I don't require to have anything at that moment in time? Well, the easiest thing is when you do the switch, you have like the empty thing that there's the enumeration is nil, and you can do it before the switch. If let the navigation destination is nil, then, or if let it's not nil, then I will go through the switch. Otherwise, I will return empty, and that's basically it. That gets rid of a lot of boilerplate that gets executed every time. Okay. More questions. The guys from LeverX are preparing some other press, hopefully, for the best question. No? No? No questions. You can ask questions just for the sake of it. There's a question over there.
Hi, I have
Thank you for the trip. I mean, like, I really appreciate your.
No problem. Maybe it's kind of philosophical question, but
Love those.
MVVM pattern was used to bind view and model. And do you think that in Swift UI we should just drop creating view models, because basically we already have in Swift UI view all binding, right? So do you think that view models, because I've saw many blog posts about just dropping off view models because it was used only in UIKit, but in Swift UI we shouldn't. What do you think about it?
I love the question. How much time do we have? 8 minutes. No, I will do it shorter than that. But let me start with history. I'm sorry, but this question is asking for it. View models were, although people wrongly identify view models to Microsoft and Silverlight, the truth is that the pattern itself was created by none other than Martin Fowler, and he called those presentation model. It isn't as catchy probably as model view model, but presentation model is what he called the view models. And originally, the binding part wasn't there. So it was about notifications as we are doing now through observation in the pattern. But coming back to your question, I would say, please don't get rid of the view model, in my opinion. And I will tell you why. View models are far more testable than views in Swift UI. UIKit had a little bit of visibility on the UIKit view once it was created. However, because of the nature of Swift UI, it gets very hard to get to know whether a label is displaying some content or not compared to, unless you use UI automation. And this UI automation is not what you want to do fast tests in the UI. So having the view model exposing some properties and exposing some events, observable events, that you can really test very fast makes your life easier if you want to test each of your views without testing the views, okay? So getting rid of the view model would affect your testability in the application. I wouldn't do that. I wouldn't recommend you to do that. Does it solve your question?
Yes, thank you.
Any other? Oh, okay. So no worries, I will say.
This will be a quick one. Do you think that's after the view model question, it's that MVVM is the best for Swift UI, or there is maybe something better, like directional or something like that?
Great question. So I don't think any architecture is the best. Yeah, any at all. So it really depends on your needs. There are some architectures that are not usable in some environments. So for example, even though I like Model View Presenter, Model View Presenter cannot be used with Swift UI. Model View Presenter is telling the view what to do, while here you cannot talk to the view because you cannot get the identifier or provide methods in the view that can be invoked from the other side. So there are some patterns that you cannot use with Swift UI, Model View Presenter or Model View Controller. But whether you want to use Model View, View Model, or Model View Intent, it really depends on your needs. I am a little bit reluctant of Model View Intent because it usually comes associated to a persistent storage that keeps track. It's like the event sourcing part of the backend move onto the front end. I'm going to remember everything that happened in your life since you were a kid, and I will take notes of everything that happened there in order to remember that. Not a bad idea, because it provides you some traceability and helps you to do the debugging, but sometimes you have the feeling that all the implementations that you see, at the end, they break some part of the model view intent. Or they are really complex, or the application is so trivial that it doesn't matter. So, not a big fan of model view intent. I think it has advantages, and I believe that one thing that I suggest all of you is when you hear about one of this architecture, get a good example and try to put it in place in another application of yours and try to figure out whether that makes sense to you or not. Sometimes it's like, this might be a wonderful idea, but I'm not going to do this ever. I think that, for example, with Christoph's solution with Sorcery, you can generate some of the code if you have repeatability here. But still, it may not suit your needs. And if it doesn't so, it's good to have something that you are going to be able to live with, rather than something that is very fancy and appears in every new article this year. So, nothing against MVI, okay? I hope there was no recording of that.
I have one more. Yes, I only assume that these dependencies that we are passing over, there are observed objects, and the question is, do you still find a place where environment object could be used with connector pattern? And the second part of the question, do you find any place where state object could be used for holding view models, like inside of the view? I know it can be tricky with injection and with test.
Okay. I think these are two excellent questions. Let me start with the first one. So regarding the dependency injection inside of the connector, and whether you want to have these dependencies always injected through the dependency injection or through the environment, which I understood that was the first question, I believe that the environment has some applications. For example, if you're using the Realm SDK, it is like the easy way to provide the Realm SDK instance to the rest of your environment. But that creates coupling. So one of the things that I was asking at the beginning is, do you isolate your persistence? And I don't know if you were doing, not you personally, the people in the room, were doing iOS development like in 2015, but if you did, probably you will remember parse, okay? And how cool it was to have parse in your applications, and everybody was able to, in a very cheap model, have synchronization to the cloud, and parse was acquired by Facebook, and people were even happier because now Facebook is going to maintain this until they didn't. And they discontinued, and they offered like the server in a way that you could run it by yourself, but it was a pain in the ass, and you were trying to use parse because you didn't want to maintain a server. So let's be honest. So having this accopplation of your code, coupling of your code between the view and what is expected, or what you have passed through dependencies, is tricky. You have to do it in a way that you can replace things properly without having to affect those. One of the things that probably you have noticed is that when you create a view, sometimes you define the actual view model that is going to be used in this view. And I want to see hands up here, please. So you have created your preview of your view, and it doesn't work because you have to inject so many things to have this view running in the preview that it is not worth having the preview. Okay, so once you have an actual view, sometimes you have to inject too many things, and that doesn't help. If you're having this issue, it's because of coupling. So what you should actually do is to use a protocol that represents your view model and create a mock of your view model to inject it in your view. That way, your preview, sorry, I was looking for the right word, your preview will be able to show whatever you want, and you will be able to tweak the view there. You don't need an actual complete implementation of the view model. You do need something that will help to set up the view and run it in the preview. That's it. Having all those things, like depending on the environment, makes things trickier. So I'm not completely against it in any case, but I will try to avoid it as much as possible. Okay? And sorry, but I missed track of your second question.
Okay, I can repeat. The second one was, do you find any place where holding the view model as the state object is valid? Basically.
So yes, here is because of memory retention. So sometimes you want to have a way to avoid the view model being created again. So that is why you need the state object. And I believe that it has uses.
Yeah, but then you don't inject but create it in the view, and it may be tricky to then...
Well, you can use in the main view, you can create the state object in the application.
And then underneath is observed object.
Yeah.
Basically. But like in the... Is there, maybe I will rephrase the question. So is there some place where you find it useful when creating a state object of the view model, which then is not passed to other views? So like the view is the single holder of this view model. And
yeah, I mean, like as much as you can, you should try to have the view as the single holder for the view model. Sometimes you require a state object for that, but this I mean, like you really have to ensure that this is the case, and then still use the injection to provide this view model to the state object. Okay? Are we all set?
I think that was the final question. Thank you, Jorge.
Thank you very much.